Behind me is one of the most ambitious scientific facilities ever created, the Large Hadron Collider. This 27-kilometer underground ring near Geneva, Switzerland, is the site of mind-bending experiments, some of which may bring us closer to uncovering the universe's deepest secrets. But recently, something unusual happened here. Scientists at CERN were searching for elusive particles known as magnetic monopoles, and during that search, something entirely unexpected occurred. A crack opened in the Earth's magnetic field and remained open for 14 hours. Is this just a coincidence? Or are we on the verge of discovering something beyond our current understanding of physics? Let's start with the basics. Every magnet you've ever seen, from fridge magnets to the Earth itself, has two poles, north and south. Split a magnet, and you just get two smaller magnets, each with its own poles. But physicists have long theorized the existence of something called a magnetic monopole, a particle with only one magnetic charge, either north or south. Think of it as a magnetic version of an electron, a single-pole entity. According to some models that extend beyond the standard model of particle physics, these particles should exist, and if they do, they could help explain why electric charge is quantized, why it comes in fixed, discrete units. Despite more than a century of searching, magnetic monopoles have never been detected, not in nature, not in space, and not in any particle collider until now. In July of this year, just days after the LHC was restarted at full power, researchers turned their focus toward a phenomenon known as the Schwinger effect. It's a hypothetical event in which incredibly strong magnetic fields spontaneously create particles and their antiparticles, possibly including magnetic monopoles. So they did something bold. They collided beams of lead nuclei at near-light speeds. The result? The most powerful magnetic field ever created in a lab, measuring an estimated 10 to the power of 16 teslas. That's 2 billion times stronger than the magnets on your fridge and 100,000 times stronger than the magnetic fields of magnetars, some of the most extreme objects in the universe. But even with these godlike energies, no magnetic monopoles appeared. This finding placed the strongest ever limits on the possible mass of these particles. If they exist, they must be at least 70 times heavier than a proton. But the most startling twist came afterward. Around the same time as these experiments, something happened that raised eyebrows, not just in the scientific community, but all over social media. The Earth's magnetic field experienced a temporary breach. A crack, in layman's terms, opened in the geomagnetic shield that protects us from solar radiation. And it stayed open for nearly 14 hours. Now, to be clear, cracks in the magnetic field are not unheard of. They occurred during interactions with charged particles from the sun. But the timing and duration of this event were unusual, sparking theories that CERN's powerful experiments might be influencing more than just subatomic particles. Is this coincidence or cause for concern? The Earth's magnetic field plays a crucial role in making our planet habitable. It shields us from solar winds, streams of charged particles that could otherwise strip away the ozone layer and fry our satellites. This particular breach was caused by a phenomenon known as a co-rotating interaction region, or CIR. CIRs form when fast-moving solar wind overtakes slower streams, creating shock waves and turbulent magnetic fields. The result? A G1-class geomagnetic storm that hit the Earth on July 7th, creating spectacular auroras and briefly opening our magnetic field. According to NOAA scientists, this event was intensified by a coronal mass ejection embedded in the solar wind, essentially a massive bubble of plasma launched from the sun, traveling at millions of miles per hour. But there's another magnetic mystery on Earth, and it's been developing for decades. It's called the South Atlantic Anomaly, a region stretching over parts of South America and Africa, where the magnetic field is significantly weaker than elsewhere on the planet. This weakened field poses a real challenge for satellites. As they pass through this region in low Earth orbit, they are exposed to higher levels of cosmic radiation, which can interfere with electronics, short-circuit instruments, and even cause permanent damage. NASA and other space agencies have been monitoring this anomaly closely. And now, there's growing concern. Is the magnetic field weakening globally? Could it signal an upcoming pole reversal, or something we haven't yet predicted? Our sun has been particularly active lately. In a recent stretch, 17 eruptions were detected from a single sunspot cluster. 2 of them hit Earth at nearly 2 million miles per hour. These solar flares, massive bursts of radiation, can disrupt communications, interfere with GPS, and knock out power grids. Just ask SpaceX. In early 2022, they lost 40 satellites just hours after launch because of an unexpected geomagnetic storm. One of the most famous solar events in history, the Carrington event of 1859, caused telegraph systems around the world to fail and produced auroras visible near the equator. If something like that happened today, it could cripple the global internet in minutes. To some, these events, CERN's experiments, breaches in the magnetic field, the South Atlantic anomaly, and powerful solar flares might seem like isolated incidents. But taken together, they raise important questions. Are we approaching a critical threshold in our understanding of physics? Is our magnetic field changing in ways we don't fully comprehend? And should experiments like those at CERN proceed more cautiously, given the potential ripple effects across the planet? So far, scientists assure us there's no immediate danger. Cracks in the magnetic field are part of a natural process. The search for magnetic monopoles continues. And the sun, while unpredictable, has always been a fiery wild card. But the coincidences are stacking up, and they deserve our attention. Whether we're standing beneath shimmering auroras or beneath 100 meters of rock, where protons collide at unimaginable energies, one thing is clear. We are just beginning to understand the forces that shape our universe, and the ones that could reshape our world. Don't forget to like, subscribe, and let us know in the comments. Should we be more cautious with experiments like those at CERN, or are we simply witnessing science at its finest?